Most LLMs you use today already use synthetic data in its training process. It's not just a thing of the future. The large labs already use the larger models they have, like GPT-4o, to generate training data for a smaller one, like GPT-4o mini. This lets you build faster and cheaper models that, in most cases, are specialized on a certain task. And this is called distillation. But the vision for synthetic data is much bigger. You want to enable people to train specialized AI systems without having a lot of training data. And today we are talking to Adrien Morisot, an ML engineer at Cohere. And we talk about how Cohere uses synthetic data to train their models, their learnings, and how you can use synthetic data in your training, and how especially you can take what they do at large scale to a smaller scale with smaller models or for specific use cases. And we are slightly diverging from our search focus, but I wanted to create a deeper dive into synthetic data after our episode with Saahil. And in search, you can use synthetic data in a lot of places. You can generate hard negatives, you can generate training samples for classifiers or rerankers, and much more. And before we start with the podcast, I would love to know whether you have actually used synthetic data before and whether you found any use in it. And also leave a review on the platform you're listening on, like YouTube or Spotify. It helps a lot in continuing the podcast and make it bigger and better. And that's enough for me. Here's my conversation with Adrien Morisot on synthetic data.
I think so there's kind of two arcs to my synthetic journey. The first arc was maybe 2021-ish, when we had models, just generative models. And I was trying to get them to create data for themselves or create data for other embedding models or search models or classifiers. And at the time, the models were really bad. And so I tried quite hard, tried fine-tuning them, but it just didn't work. Nothing worked. Training on the model outputs would always make things worse. And so I gave up. And then I did other stuff for a while. And then relatively recently, we got models that achieved kind of step functioned up to the point where they were good enough to start being usable for kind of training themselves in small ways. And yeah, and it was an accidental rediscovery. We had a very pressing customer ask that we really had to fix. And so the default way to fix some kind of model issues is to run annotation jobs with humans. So you say, okay, like here's the task, and you create some data to fix this issue. And there was just, the customer ask was so pressing that we didn't have time to run a normal, full-fledged annotation job with human beings. And so we're like, okay, we have to accelerate this somehow. And so the kind of path to that was using the model. And so have the model kind of do as much of the work as possible, somewhat guided by humans, but still mostly model work. And it was a very intense month of work, but we ended up developing lots of useful techniques to figure out how to get the model to improve itself on a variety of axes. And then we realized, okay, this is very promising. Let's turn this into a full-fledged team and kind of more coordinated effort. And we've been doing that since then.
Nice. And how do you think synthetic data fits into the evolution of AI or like software at large?
Yeah, I think it's actually very fundamental, or maybe it's because I'm clearly biased, but I think it's part of a grand arc. It's like the beginning of a grand arc of the evolution of AI. And so one analogy I've been thinking about a lot recently is, you know how the beginning of computing was like very hands-on. You tell the machine exactly what to do. So it's okay, there's like a binary number in this register, binary number in this register. We're going to have them flow through this particular circuit. And then at the end, this will be like the subtraction of these two binary numbers. And you can program in assembly code this stuff. And it works. And it's the closest thing to the metal that there is, but it's also incredibly slow, incredibly difficult, incredibly painful. It's not something that you do for fun. And then you fast forward through the history of computing, and then you build all these abstractions around it. And at the end, you have Python, which is very close to English. Oh, if this, do this, you define, and then you give it a pleasant function name, and then it just adds two numbers, multiplies them. And so you have this kind of software 1.0 evolution from something incredibly painful to something quite pleasant and easy to use. And I think there's this second arc of programming, which is not software 1.0. It's more about telling a neural network what to do. So you have a big neural network, and then you have a bunch of inputs and a bunch of outputs, and you say, okay, for these inputs, map it to these outputs. And the original way to train these neural networks was very painful. You harvest data usually manually, and it's stressful and difficult and painful. You have to find tricks, you find data augmentation tricks. All of this is not particularly pleasant or easy. But I think, and in the past, you couldn't use a bigger, smarter model to create data. You still had to either get humans to do it or find clever ways to scrape the data that you needed. But now the biggest and most competent models are powerful enough that you can just tell them, okay, I need data of this specific format, help me map this type of input to this type of output, and then give me a bunch of examples of these inputs and correspondingly these outputs, and then I will use this data to train the neural network on, and it works reasonably well now. And so it feels like it's still painful. There's still pitfalls. It's probably still in the C world rather than assembly, but the path to having kind of the Python of being able to program neural networks is becoming more and more clear. I think there's more and more of an ecosystem around creating synthetic data, and it will only get better, and the models will continue improving too. So that will help a lot. So yeah, I think it's quite fundamental. Like if you have models that are capable of creating data for themselves, that it feels very powerful.
Yeah, and I think it's really interesting because I think the software 3.0 is touching it from different levels. Like on the one side, you have the readable code which is interpreted or compiled into a machine program, but at the same time, you have the more data-driven side, like neural nets and stuff like that, which is turned into a statistically based machine program. And now you have the synthetic data generation, which takes over the second part, but you can also generate code very well, which takes over the first part. So it's like double trouble in the end.
Yeah, it's quite an interesting synthesis. Yeah, lots of strange things coming together. But the future will be very exciting.
Yeah, and how does synthetic data enable this? Is it like, what was the struggle so far where we couldn't basically curate the data sets or get the data sets just from the internet or from existing documents?
Yeah, there's always, for a long time, you can always kind of be clever about your data harvesting or data gathering. There's many examples. So the internet is like a huge place. So you can find lots and lots of random stuff in it. And if you needed a data set, odds are you could twist and kind of cleverly reformat parts of the internet to suit your needs. So maybe one example of this, let's say you want to train a model that's good at recognizing that two questions are similar to each other. Then you can think very hard and be like, where on the internet are there instances of questions that are similar to each other that are labeled as such that I can figure out how to scrape? And then if you think hard enough, you realize, on forums, there's often a little tag that says duplicate sometimes. If you go on Stack Overflow, it'll say something, this is a duplicate question to this. Or on Cohere, you'll find, this is a duplicate question to this. And so if you just scrape those websites, then you can gather a bunch of question pairs and then cleverly come up with large quantities of data around questions that are not phrased exactly the same, but similar semantics. And so that lots of machine learning for a long time was about this. You had an idea you want some stuff, you want some data in a specific format, and you go on the internet and you try to harvest it that way. This is not trivial. This is a day's work, 2 days' work, depends how good your scraping capabilities are, depends. Most of the time, you'll be able to find something on the internet that kind of loosely matches what you want. But sometimes it's just impossible. And the reason synthetic data is useful, you can just ask the model. So you can say, hello, I have two similarly phrased questions, two questions with similar semantics, but different kind of phrasings. And then the model will just say, sure, how's this? And then it gives you one, and you're like, okay. And you shade on your prompt to figure out what is reasonable and what is not reasonable until you find something that satisfies you, and then you generate large quantities of this. Yeah, and then you have, yeah, and so you're trading, yeah, you're doing everything in English rather than in beautiful soup and requests.
And I'm really curious, how does this actually look like? What are you feeding into the model to actually get the good output that you get? Like, in the end, you can generate, for example, questions. What do you feed in? Do you feed in like a user persona, similar questions? What are like the different inputs you use?
Yeah, so I think the user persona that you're referring to, is it from that 1 billion personas paper? Is that a
Yeah.
reference? Yeah. For the audience, there was this very cool paper. Okay, so maybe to zoom back out a bit, if you just naively ask the model, hey, give me two questions with similar semantics but different phrasings, and you do it once, the model will say, sure, here's one. And then you're like, great, happy, let me get 1,000 of these. So you inject this, or like you regenerate an answer to this prompt 1,000 times. That doesn't work because the model has no kind of recollection of what it said across different chat calls. And so you don't really know, like you're asking for 1,000 different ones, you might get 15 different ones because the model might just repeat. And so this is pervasive across all synthetic data generation. And so the clever way around this is to inject more noise into the prompt such that you get a diverse output. And so one cool technique that we'd actually discovered internally long before this personas paper was published is, okay, you go over the internet, and then there's the internet is huge, it's crazy, there's all sorts of different stuff in it. And then you ask the model, okay, here's a page from the internet, tell me something about the person who would have generated this page. Get very specific about it. And so maybe it's a cooking blog, and then they have some kind of detail about their family. It's like a Filipino dish or something. And so the model's, okay, this is a Filipino chef who loves their family, blah, blah, blah. And so that's one persona. And then you do this in parallel across large parts of or like 1 billion web pages. And then you get, okay, you have the Filipino nurse, and then you have the Haitian sprinter, and then you have the French swimmer or something. And then you've accumulated very precise personas. And then where synth stuff comes into play is, rather than asking just, can you give me two questions with similar semantics but different phrasings? You have, can you give me two questions with similar semantics and different phrasings? By the way, you are a Filipino chef, and this is your very precise personality. Use this to create the questions, and then the questions will be very particular to that Filipino nurse's life or that French swimmer's life. And then this kind of averages out to a very diverse data set, as diverse as the internet. So that's a key synthetic data trick, is to inject as much diversity using the internet as possible.
What are other options you guys have explored to generate like that diversity, but within the constraints of the actual tasks you want to solve?
Yeah, so we've explored a lot. It's a central problem. One of them, which dates back a long time ago, people were using this on top of GPT-3, was just injecting a random number in the prompt. So at the top of you have everything the same, the prompt is the same, but at the top of the prompt you have a random number. This works okay, it helps a little bit, but it's not great. The personas and using the diversity of the internet is definitely better than using the diversity of a random number generator. And yeah, I think we've tried other stuff, but the most successful stuff so far has been using the innate diversity of the internet to create richer and more diverse synthetic data. There's some other kind of very narrow techniques. Okay, if you want to guide the model more specifically towards generating maybe like 10 different types of things, let's say you want either A or B or C or D or criteria 1 through 10, what I often do is I put those in a Python list and then random subsample 3 and shuffle, and then just have those in the prompt. You get this 3 choose 10 possible prompts. And then if you just work your way through those, the model will be decently diverse. But I think the finding has been mostly that the internet is diverse enough for most purposes.
Yeah. And for people who are not like
Yes.
at your guys' scale, who are building mostly like more task specific data sets, how would you actually go about that if you're building a financial models? How
Yeah.
would you go about actually controlling the synthetic data to stay within the domain, but still be diverse enough to cover a broad basis?
Yeah, I think, yeah. So maybe another example that we haven't touched on yet is few shotting. Usually few shotting is dangerous because the point of few shotting is you narrow the diversity of your output, you tailor it much more precisely. Maybe in this case that would be a good thing, right? Because if you're trying to generate either analyses of financial models or to create financial models in the first place, then then it's probably important to have a very precise structure for your output. And so if you add examples of the desired output in the prompt, maybe 2, 3, 4 times, then you'll be golden.
And how much manual curation is actually still involved? Like, how much do you actually go over the data set after you generated it to check whether it's of high quality?
Yeah, so I think a lot. And that's the reason we're still in C or C++ land and not Python. It's basically, so yeah, I talked earlier about the software 1.0 where you like write code to tell the machine what to do. In software 2.0, which is training neural networks to do something, the way you program the network is with the data. And so in the same way that you have to reread your code obsessively and add tests and you get PR reviews, so someone, maybe one person, maybe two people look over the code and step through it and try to understand deeply what's going on. The same is true for software 2.0, but what you have to do is not read code, but look at data. So look at examples of input-output pairs and just be like, okay, this makes sense, this makes sense. Yeah, would you trust a PR review if it stated at the top that it only read 1% of the lines of code and that they looked good? Probably not, right? So it's the same for synth stuff. You have to read over the output obsessively, make sure that the inputs make sense, that they're close to the distribution of inputs that you're expecting, that your outputs make sense, that they're kind of exactly what you want with no confusion. So you have to be pretty obsessive about just bathing in the data at all times, just swimming in it, being like, oh, okay, this is interesting, this is neat. Data has to be both, there has to be both large quantities of data and also high quality, meaning often diverse inputs, diverse outputs. And yeah, that's the way that you get a performance model.
Are you automating this? So are you evaluating all the different inputs, outputs you generate and trying to create like the thing on GitHub all the time, like test coverage 98%?
Yeah, so the equivalent versions of that are just measuring, or there's some automated ways, right? There's measuring diversity. So, some smooth brain, simple ones like, okay, how many n-grams do overlap across all your data points? We have some clustering techniques like, okay, maybe they're different, maybe n-grams don't overlap, but maybe they're all very semantically similar. And so we cluster them using our embeddings and then see the overlap. So that's one flavor of automated metric. And there are more, but a very fundamental thing is still to just manually read the data. Oh, another thing, you can look at axes. You can look at interesting axes. So if you take the extrema of different axes, you'll often get interesting things. So if you take the longest data point, it might be weird. If you take the very shortest data point, the shortest 5 or the shortest 10, it might be weird. If you take the ones with the highest likelihood, according to the model, the lowest likelihood, according to the model, that might be interesting too. And yeah, various automated measures. If you have code, like how many tests pass for something, if you're generating tests, whether something compiles or not, things like that.
And why do you think now is the right time to actually start to fine-tune models with synthetic data?
Oh, because we've tried it and it works now. Whereas before we tried it and it did not work. I think if now is the time, in the sense that it's like, so one thing that I think all the the big AI labs do is have very large quantities of human labelers, human annotators. So we have, at Cohere, we have an internal annotator army plus vendors. This is hundreds of human beings labeling data. And most companies in the world cannot do this. It's just very unreasonable to hire a bunch of human beings to label data. It's very painful. It requires much more expertise than maybe you'd naively expect. It's a whole muscle to build to run a human annotation job. It's very difficult, especially if you want to do it well. But I think Now the synthetic data has gotten to a point where you can start doing some of the tasks that an annotator army would do, and do it for the cost, for not human cost, for kind of GPU cost, which is 1 or 2 orders of magnitude cheaper.
Yeah. Do you actually, because when you're running human annotations, you often use multiple evaluators on the same type of data and look how well they basically correlate. And what you often find is basically there's quite a drastic difference, even if you do like more of a classification task and stuff like that. Do you actually try to use like multiple different models to generate the synthetic data and basically then cross correlate?
Yeah. So we mostly use our own models just because we have them and they're good. Recently, NVIDIA released Nemotron, which is like targeted specifically at, or the way they marketed it at least was you can use this model fully open source to create large quantities of synthetic data. So we might start using that. There's someone working on converting it to our infra right now. And yeah, you'd intuitively think that this would make sense to increase the diversity, right? If a core challenge of synthetic data is lack of diversity, then you'd expect using lots of different models to help. I think I half buy that. I think it's just the way in which the models are, or another way to inject diversity, which is much more Cohere specific, is just like training the models in different ways. So you have different recipes for training models, and those recipes tend to produce quite different behaviors. And so if you just get diversity that way by prompting, by putting the same prompt into 3 differently trained models and harvesting different outputs, that works too.
And
Not, yeah.
I think you can flip the next thing in 2 different directions. So basically, behavioral cloning. For one, how do you actually avoid behavioral cloning with synthetic data that you're just generating more of the same stuff? But also, how do you actually use synthetic data to overcome behavioral cloning in training models? Because you often lack enough training data to get like a robust or diverse enough coverage.
Wait, what? Maybe could you expand on what you mean by behavioral cloning?
So behavioral cloning basically means that your training data set, because often in especially like generative AI, there are a lot of different ways to answer the same question, but you do not have all of the different ways or most of the different ways in your training data set. So the model basically overfits on what it has seen and isn't able to do stuff it hasn't seen before.
Yeah, I think maybe some attempt at an answer would be a warning. Like if it's not, so the synthetic data is not a panacea, i.e., if you create synthetic data and it's wrong or bad and you put it back into the model, it will definitely get worse. So you have to make sure that the outputs of the model are correct before you feed them back into it. If the outputs of the model are correct and you have some guarantees of this, then it's probably just okay. If you show the model examples of okay data, okay, in a diverse way, then the model will probably get better. So maybe one more concrete thing is, let's say that you want your model to get better at very precise flavor of math or something. Like let's say you want it to be really good at calculus. Then if you ask it casually for the integral between 0 and 2 pi of sine x over x or something, and it just spits something out, and you have no idea whether or not this is correct. If you feed it back into the model, it'll be like, okay, this is definitely the correct derivation. In the future, I will do this. But if you have some way of verifying the output, maybe with a symbolic solver or something, like you extract the stuff from SciPy, and then you turn it into code, and then you make sure that the model's answer indeed matches up with reality, then you can put that answer back into the model. So yeah, there's no free lunch, and that you need to do work. If you're not confident that the model can do the task, you need to do work to filter the bad data points. Either using humans or using code or some combination. Yeah, there's no kind of crazy free lunch.
Yeah. And because you touched on it before, on the especially like diversity of synthetic data, which is basically like n-grams, cluster analysis, semantic similarity, how do you go into the opposite? So basically, if you want to train a model or if you want to do a domain adaptation of a model, how do you actually try to ensure that the model or the outputs and inputs stick to the domain and how the words are used in that domain.
Yeah, maybe could you make the question more pointed? Pick a domain.
So what I've done often is like mostly, especially in finance, and the lingo in finance is a lot different than the lingo on like most data or websites the models were trained. The model just doesn't have the right probabilities. The log props aren't fine-tuned on that domain.
Yeah, so maybe one thing is to just fill up your context with kind of correct documents. So either the model is capable zero shot of just speaking like a financier or a finance person. If it's not, you can probably help it along. Since context lengths are so big, you can pick your favorite piece of finance writing that has all the correct lingo that you want and just stick it in the prompt and add some part of the prompt indicating that you want the model to behave in the or speak with the same style as the text above. Maybe you add a glossary of common finance terms that the model might not know, but that feels closer to assembly and early C, in the sense that I would expect the model to get all models over time to get much better at modeling finance lingo. Maybe, yeah, like within a few years, I'd be shocked if the model didn't perfectly understand all of the finance lingo, just because there has to be so much of it on the internet, and all the big LLM companies are doing a better and better job of scraping the internet and figuring out what should be read, what's important. And obviously, finance is such a huge, obvious use case for LLMs that, yeah, I'd expect models to get much better at that, at least understanding the log probes and the lingo of finance.
Yeah.
Are you finding that the models are not capable of dealing with kind of finance lingo properly?
Yeah, especially I think so. Most of the financial use cases we do is really heavy in like information extraction from financial documents.
Mm-hmm.
And if you look especially at like annual reports and stuff like that,
Mm-hmm.
it's very specific, and there is so much boilerplate which you usually can't just ignore. But this boilerplate actually, in my opinion, really fucks up the log props, especially because it's always identical or mostly identical. And then the more important bits are very different depending on like the industry you're in, but also what accounting rules you have to comply with. And even the like different accounting firms have different styles, like whether you use Deloitte, EY, Rowan Berger, and stuff like that.
I'm familiar. My girlfriend works at KPMG. Yeah.
And it's quite an interesting challenge, but I think it's very similar to legal in the end. Each country in legal is different because you have your own laws and rules, and it has the same challenge, like so much boilerplate in contracts, which you should just ignore for the models because it's pretty much irrelevant.
Yeah. Until that one clause.
Until that one clause, yeah. And can you walk us a little bit through like how does your method or way of working look like for like improving the synthetic data set? Like only not even touching like the model, but really looking at like inputs, output, fine-tuning the model, evaluating it, and then basically iterating.
Yeah, it probably starts with evals. So let's say that you care about a specific issue, like model pathology, then you want to have a reliable way of measuring that pathology, ideally in an automated way. Otherwise, things take much longer and are much more expensive to fix. But usually you can break down. For a long time, model evaluation was like using terrible techniques like blue scores, which are terrible, or just like simple classification evals, which don't work very well. Now models have gotten good enough that they can pull out information reliably from their own generations, and so you can compose an evaluation suite. That's okay. Make sure that this property, like for a given prompt, make sure that this property is maintained, this property is maintained, this property is maintained, and then you can fully automate your entire eval process. Once you have that going, then you can just create synthetic data run an annotation job, fine-tune the model. The fine-tuning recipe is pretty standard usually. There's only really two options. There's behavioral cloning stuff where you tell the model, okay, for this input, this is exactly the type of output that you want, or PO / some sort of preference loss where you have a good completion, a bad completion, and you want You're telling the model, okay, this is the good one, this is the bad one. Make sure that you do more of this and less of this in the future. And depending on your setup, you run training, and then you see if the metric moves or not. And if the metric doesn't move, but you're confident your data is good, then you go look at the specific outputs for your specific test cases and see whether there's like ways to figure out why your model is still misbehaving. Maybe the task is too hard. It's possible, right? If you ask the model, if you're trying to distill like very complicated concepts into too small a model, even if your data is perfect, it won't work because the model has no capacity. Like asking a 3-year-old to like be very good at quantum mechanics is probably not going to happen. So if you try to teach a 1 billion parameter model something too complicated, it will just fail. But yeah, otherwise, hopefully the metrics just go up.
Can you give me an example on like the properties you're evaluating on?
Yeah, there's a suite of them. Often, so we're quite enterprise heavy, and so we work a lot with enterprise customers, and then the stuff that they tend to want is just clean syntax, often length constraints. Yeah, so one thing is like you have a GUI and you want it's like very rich, there's lots of stuff going on, and you want the LLM output to go in this little box, this like very precise box in this very precise GUI. And the designer said, okay, you have a box of this size. And so a box of this size fits 150 to 200 words. And if you go under, it looks ugly. And if you go over, it looks terrible. So it's very important that you stick there. And yeah, so it's like one type of constraint that you want. There's more. So yeah, there's repetitiveness. There's not hallucinating. You can do that too. There's different flavors of criteria that kind of span. If you've worked with LLMs, you'd recognize them. But kind of you basically just want if you have a constraint in your prompt, go write it between 100 and 200 words, or don't be repetitive, or make sure that you format it in Markdown. You want all of those constraints to be adhered to very precisely, since you bothered to put them in your prompt. And so you can just pull it out and then ask the model, hey, is this Markdown properly formatted? Actually, for that one, you could probably just run a piece of code to do that. Or you can say, oh, is this text repetitive? The models are pretty good at detecting that. Is this text referring to the right thing? Stuff like that. Is it in the right tense?
Yeah. Are you also using LLMs as a judge in there?
Oh, yeah.
How do you actually evaluate whether the LLM as a judge is well correlated with human judgments or actual results?
Yeah, a different team, a team at Cohere that I used to work on, the RAG team, found that it seems to be the industry standard now to use LLMs as a judge, like quite often, just because humans are so expensive and not necessarily that reliable. And yeah, if you basically the path to getting this to work well is if you break down the task enough. If you just naively ask, hey, is this answer good? Is it adhering to the prompt? Then you're not going to get a particularly compelling response. But if you go through manually and you say, okay, you just ask one thing of the LLMs, like, hey, is this thing repetitive? And then you kind of sanity check by writing one repetitive thing. And then if it says it's repetitive, then you're like, great. And then copy paste Barack Obama's Wikipedia page and you say, hey, is this repetitive? And it says no, then you're like, great. Or you do some simple sanity checks to make sure that your prompt is working. But otherwise, the models, like we should trust the models to do quite simple things. And assessing whether or not a piece of text is in the past tense or the present tense is a simple task. Measuring whether something is repetitive or not is a simple task. And so if you have lots of constraints and you just break them out into one individual prompt, so the model has all of its intellect to focus on this one prompt, then it works usually quite well.
Have you actually evaluated what works best, whether to put out basically a score on a rubric like 0 to 10, whether to put out like classes like bad, good, okay, or even like just binary classifications?
Yeah, yes. It's not super clear. And then we ended up kind of half fine-tuning for a specific way that we've used since. So yeah, it's not obvious which is the most correct. It probably just depends on the setup. But we use a mix of all of that, yeah, like true, false, or 0 to 10. I personally never use 0 to 10. It feels a bit sketch. Like, how do you tell between 4 or 5 or 6? It's not too meaningful. I prefer the binary ones.
Yep. I think if you do like a scale, the way Prometheus does it, so the paper, they basically have you define the entire rubric and what the different scores should mean, which I think is probably the best way if you use scores. I prefer binary evaluations as well, because especially if you have some more hard-coded stuff, most of that is binary as well. If you're assessing whether code runs,
Yeah,
it's true or false. If
yeah,
you're assessing whether the markdown is formatted properly, it's also true or false.
yeah. And it's everything becomes simpler when it's binary. Yeah, but yeah, recently someone did add like a scale out of 5, and then add 1 point if this criteria, add another point if this criteria, add another point
Yeah.
if this criteria, and that works okay. Yeah, I think we're still in the early days of this technique, and the models are still evolving so fast that we probably should never be too obsessive about any particular technique. We should just be flexible.
Yeah. What do you think people or regular AI people should take away? Because nearly no one is at Cohere scale. Most work on like smaller domain specific language models or build wrappers. How can they use the stuff we just talked about or what you're researching in their AI systems?
Yes, I think there's a lot to be done. It's the kind of, I really do think of this as the beginning of a new kind of paradigm in computing where you can move from terrible programming of neural networks, where it's so painful, so uncomfortable, to something where it's closer to how humans think. We can basically program the neural network purely using English and a Python for loop. And so tangibly what I would do, I would get the models to first kind of evaluate stuff. So, or yeah, if you have a system that would benefit, where right now a human is looking over it, or sampling from some outputs, just have the model kind of synthetically start evaluating stuff, giving back quantities, measuring how well you're doing. Maybe this is not super tangible, but it's a big class of problems where the models are good enough to evaluate stuff now, according to your criteria, of course. And then maybe if you're the one training neural networks at your company, maybe you have some custom search thing, or you have some custom kind of small generative models that you're fine tuning. And yeah, the way to program those things effectively is probably no longer going through the internet and scraping and finding data or human annotation. It's probably just politely asking the model to create large quantities of data for you, plugging them into your system, and then fine tuning, and then seeing if that works better. And it probably should. And as the models get better and better, it should get simpler and simpler to get this working well. And the benefits of this are, right now, you have these very big, very expensive models, and they're slow. And so if you have a specific thing that you want to do, and you only want to do that, and you want to do nothing else, then you can achieve very large cost savings just by creating, it's a weird thing, but you have this Python function, and it's fine, but it's slow, and you want to distill it. You want to have the fastest possible program without dealing with the difficulties of, you want, without the Python memory overheads and all the things that make Python slow and clunky. The way to do that is just create synthetic data using a very big, very powerful model and distill it down into a tiny one that does the thing that you want really well and really fast, really cheap.
Yeah, and especially I think like with LLMs, creating data sets for classification now is so easy and so cheap.
Yeah.
It's crazy.
Agree. Yeah.
What are like your favorite tools? We talked about you would love to see more like small classifiers, that they are a little bit of an underappreciated technology nowadays, because people just slap an LLM with some structured generation on top of it. What are like your favorite libraries, your favorite model types you use nowadays? Are you still T5 and BERT?
No, it depends what for. But yeah, I basically use the whole Cohere stack to do all sorts of stuff. We weirdly train classifiers, and we have generative models and embedding models, rerankers. That's basically all you need to do lots of very useful things. And yeah, I think my favorite library is one that hasn't been built yet. I really want someone to build it. And we can see these kind of nascent trends towards creating synthetic data to train neural networks. One thing that hasn't been built yet is a whole ecosystem around tooling to make that happen. So when you write code, you get code review that happens in GitLab or GitHub. And when you create data for models, that happens in GCS buckets or something, or AWS buckets. And it's opaque. There's the tooling around data is very poor, especially like internally. We have something that's fine, but there is not yet a GitHub for data, and there really should be, because it's so critical, and it's clear that in the future, that whoever builds this will be rich and famous.
Have you checked out LakeFS? Do you know it?
No, I don't know it. Maybe I shouldn't.
It's a library, and they are basically building what you said, and they are basically having or have built a metadata engine to manage data versions. And they frame themselves, as you mentioned, Git for data.
Okay. What is this again?
LakeFS.
LakeFS.
Yeah.
Like file storage. Is the FS for file storage?
Yeah. And they're basically like building on a different data lakes, on object storage especially. And for me, they seem more like basically like a table format in the end as well, and using that for versioning of the different files.
Okay.
Nice. And if people want to start building the stuff we just talked about, where would you point them? Where should they go?
They should use all Cohere tools because they're great. And yeah, we've released the weights for some of our models too, which I think most people haven't. That's cool.
Yeah. And if people want to follow along with you, where can they do that? Where would you point them?
Great question. I recently got back on Twitter, but I have a kind of tortured relationship with that platform. But I'm at Kale Divergence, Kale Divergence.
So what can we take away when we want to use synthetic data in our training processes? I think, first of all, like quality is key, which isn't a surprise. But even though synthetic data seems like it's completely automated, it really isn't. They are building a lot of custom filters to keep the quality high, but also make human checks on the samples to actually ensure that the training data is good. Because like bad synthetic data is likely worse than having no data at all. And there are a lot of different ways they use, like pulling out the key information, for example, from the different samples and analyzing whether it lines up with what you're training for, checking semantic clusters, running auto checks for diversity, which can also be done over or through semantic similarity, but also n-gram overlap and other like more traditional NLP metrics, and also looking at edge cases. So for example, you can look at the lengths of the different texts you're generating and just see, okay, do I have any outliers like really short text or really long text, and manually inspect them and filter them out if they don't have like the passing quality. And for that, basically, you try to automate as much as possible, and then try to flag as like the potential bad examples for human review, which you can't filter out automatically. And in case of the big labs, they for sure have like additional classifiers they have trained. So likely a few hundred people just label examples where they are good synthetic data samples or not. And then they train a classifier on it to basically classify the rest of them. And then through that, they already have a filtering algorithm. Since you likely are not working at your scale, you have to do it by hand. But it also means that you have to check a lot of less examples. And the second part is like implement a quality control flow. So use a synthetic data to train a new model, train it, but actually check whether it improved on your test data, which should come from the real world. So make sure that your test data still is real world data that you actually have seen in production, because only through that you can actually be sure that you're not overfitting on a certain set of cases. And the testing approaches, maybe to go into that again, I think they had a bunch of interesting mentions. For example, use code for basic checks, like for example, markdown formatting, valid JSON formatting. Use AI judges to rather judge simple things like, is it repeating itself and is it like well formatted? And not in the terms of like markdown formatting, but rather text structure, and break it into like a lot of simple yes or no questions over having it grade something complex on a scale from 1 to 5. And also never trust the AI judgment without any sanity checks. So you should always add an additional layer on top of the AI judge so you actually can control it as well, which basically you can imagine it like a Swiss cheese model. You have a lot of different layers, and when in one layer you're using AI, you have a layer on top of it, which is more like a heuristic hard-coded or like a human review, which actually validates the results of the AI, even when you're using the AI for evaluation itself. And for domain adaptation, I think a few of obvious advices are like fill the context window with a lot of domain-specific examples, documentation, texts, add glossaries, term definitions for terms that are used in other fields as well, but have a different meaning in your field. Match writing styles to the target domain. What are you actually seeing? How do people write? I've came across a case where people used a search engine with like really abbreviated shortcuts, and these abbreviations were different for each company. So you actually had to do a domain adaptation to actually help the model understand what these abbreviations mean and which abbreviations are actually similar. And also check the outputs whether they stick to the domain rules. So often you can define a few rules which it has to comply with, so you can actually use them as well to check the data. And yeah, that's it. I think it's very interesting. I'm really excited whether we will see that paradigm that we can use synthetic data generation to automatically train a new model on a certain task, deploy the model and use it. It's, from my experience at the moment, I don't think it's good enough yet that you actually can rely on purely synthetic data. You always need like a few samples, or like 50-50, 50% real world, 50% synthetically generated, to ground the synthetic examples in reality. But yeah, I'm really looking forward to see like the evolution of the field, because it could speed up the entire ML and AI life cycle by a lot. Otherwise, let me know what you think and whether you want to try synthetic data. I would love to hear what are the use cases where you actually want to use it, or where you think it could be of use to you at the moment. And otherwise, share it with your friends, leave a comment, leave a review, even if it's a bad one. I always want to know what can be improved as well. It helps out a lot, making it better for you as well. And otherwise, I will catch you next week when we will continue our series on search. And because it's Christmas, I already wish you Merry Christmas, and I will catch you after Christmas. Have a good one.